Today, I'm going to be presenting with Gustavo Castro, a solution engineer, as myself, Phillip, Julian. We're both out of the Minneapolis regional office, and we're very sorry we couldn't join you today. If you hear any audio disruptions in the background, there's a symphony of snowblowers. We just got slammed last night with this storm. So I apologize if there's any audio issues in the background. That being said, we'll go ahead and start this presentation. So first, a disclaimer. I am not a coder. I utilize ArcGIS in my maps and spend a lot of time kind of working with the documentation and looking for examples to be able to provide the use of ArcGIS within my efforts within the ArcGIS platform. So if you're in that situation, whether you're a coder or a no coder, this presentation will hopefully convince you that ArcGIS Arcade is going to allow you to create those dynamic visualizations and data-driven maps that you can use in your everyday cartographic pursuits. In this presentation, we're going to explore the ins and outs of ArcGIS and show you how to use it to improve your data analysis and visualization capabilities. And by the end of this presentation, we hope that you will have a solid understanding of ArcGIS and how it can be used to improve your GIS workflows and data analysis. You should have tools and knowledge that you'll need to start experimenting with ArcGIS expressions in your maps and your analysis. And with that, we will go ahead and get started with looking at ArcGIS. So taking a quick look at the agenda, we're going to begin with an introduction to ArcGIS, where we're going to explain what ArcGIS is and how it can be used within ArcGIS. We're going to give some examples of situations where ArcGIS can be used to improve workflows or data analysis. We're going to cover some basic syntax. So this is going to include how to write expressions, the use of variables, and the use of functions. We're going to dive into data manipulation, where we can demonstrate how ArcGIS can be used to manipulate data on the fly. And this can include things like using ArcGIS to calculate field values, filter data, or classify your data. We'll talk about labeling and show how ArcGIS can be used to create dynamic labels in your maps. And this can include formatting text, adding icons or symbols, or changing label placement based on the size or scale of your map. We'll talk about visualizations, which is going to include how ArcGIS can be used to create dynamic visualizations in your map. And this can include changing symbology based on data values, creating dynamic charts or graphs, or creatively displaying your data. After that, we're going to go ahead and pause, take a quick break, and Gustavo is going to go ahead and do a demo so you can see some of these topics that we're going to cover in action. And then we will see how much time we have remaining. We can go over some tips and tricks, which is going to provide some of the best practices for working with ArcGIS expressions. We're going to talk about what's new. And then we will also go ahead and do a quick recap and have some additional resources that you can use to continue learning more about ArcGIS. So with that, let's go ahead and begin our introduction. So ArcGIS Arcade is a scripting language that creates custom expressions and calculations in ArcGIS. It's portable and lightweight, meaning you can use it across different ArcGIS products and workflows, including ArcGIS Pro, ArcGIS Online, and ArcGIS Enterprise. Arcade is secure because expressions only work within ArcGIS applications and cannot execute outside of it. You can use Arcade to create labels, render features, check attribute data, format data, and more. In ArcGIS Online, Arcade can be used for custom pop-ups and defining symbology. In Pro, it can be used for creating custom labels, symbolizing features, and creating custom fields. And in Enterprise, we can see it used for creation of custom widgets and defining custom visualization expressions. So overall, Arcade provides a flexible and portable way to perform custom calculations and expressions within ArcGIS. So continuing on that subject about how it's used within ArcGIS, let's take a look at custom labels for better visualization. So you can use Arcade expressions to display complex label information, such as combining multiple fields or adding custom text based on specific criteria. You can use arcade expressions to create custom symbols or patterns that better represent the data being visualized, such as different shapes or sizes to represent different categories. And you can use arcade expressions to adjust symbology based on specific data values, such as using a gradient fill to show population density. We can also use arcade for custom calculations and expressions for data analysis, like distances and attribute values. So we can use arcade expressions to calculate distances between features, or say find the nearest feature to a given location. We can use arcade expressions to calculate new attributes values based on complex criteria, such as creating a new field that categorizes feature based on multiple attributes. We can also use it to work with our pop-ups. So we can use arcade expressions to create custom pop-ups that show only relevant information based on the feature that's being clicked, such as displaying different fields for different feature types. And we can also use arcade expressions to format pop-up information in a more visually appealing way, such as using charts, images, or graphs to display your data. And then we can also use dynamic text elements in our layouts, like dates and map scales. So using arcade expressions, we can display the current date or time, or we can format dates in a specific way. And using arcade expressions to display the current map scale or extent, or to add custom text elements to a layout based off of specific criteria. So let's take a look at some codes. We're going to go ahead and start with our first arcade expression. And this expression converts the length attribute of a feature from meters to feet using a conversion factor of the 3 dot, et cetera, et cetera. And this expression uses the $ feature global variable to retrieve the value of the length attribute for the current feature. It's then going to multiply this value by the conversion factor of 3.2 miscellaneous to get that length value in feet. And the resulting value is going to be returned by the expression, and it will be displayed as the output. And we can see here that it's enclosed in curly braces, which is used to denote an arcade expression within a larger string expression. And the $ is being used to indicate that the expression is referencing an attribute or global variable. Arcade expressions with multiple statements are separated by semicolons. So this next arcade expression calculates the area of a circle based off of its given diameter value. It's going to first assign the value of diameter attribute from the input feature to a variable called diameter. Then it's going to calculate the radius of the circle by dividing the diameter by 2 and assigning it a variable called radius. Next, it's going to calculate the area of the circle by multiplying the value of pi by the square of the radius and assigning that to a variable called area. And finally, it's going to return the value of the area variable as a result of the expression, which represents the area of the circle that corresponds to a given diameter. Our next example is going to look at defining and assigning a value to a variable in an arcade expression. First, this one's going to declare the constant value of pi as 3.14159. Then it's going to assign the value of radius attribute from the input feature to a variable called radius. Next, it's going to calculate the area of the circle by multiplying pi by the square of the radius and assigns it into a variable called area. And finally, it's going to return the value of area as a variable as a result of the expression. And then looking at our strings, they must be enclosed in quotes. In this last example, it's going to define a variable called label text and assign it the value of a fixed string, which is going to be called the value of the field is. Then it's going to concatenate the value of a specified field denoted by field name using the feature global variable, which is going to retrieve the attribute of the current feature. And the results of the concatenation is going to be assigned to the label text variable. And finally, the expression returns the value of label text as a variable for the feature. Here we can see a little bit more of a complex example that's going to be creating a custom pop-up that includes a photo. And this arcade code is used to generate a pop-up that displays an image for each feature on a map. And here's how it works. The code starts by declaring two variables, image and name. The image variable is assigned the value of image URL attribute for the current feature, which presumably contains a URL pointing to an image file. The name variable is assigned to the value of name attribute for the current feature. The code will then create an object that contains two properties, title and content. The title property is set to the value of the name variable, which will be used in the title of the pop-up. The content property is an array that contains a single object, and the object has a type property set to media, which indicates that it'll display a piece of media in the pop-up. The media infos property is an array that contains a single object, and this object has a type property set to image, which indicates that it'll display an image. The value of the property of this object is an object that contains a single property, source URL, and the value of this property is set to the value of the image variable, which contains the URL of the image of the current feature. So basically what's going on is this arcade code retrieves the URL of an image for each feature in the map. It's going to create a pop-up with the feature's name as a title, and it's going to display the image in the pop-up. And then we can also look at creating custom labels that use conditional formatting to change font color or size based off of feature's attribute value. This code is going to be used to create custom labels with color-coded symbols based on a threshold value. The variables label and value are assigned to the values of the field name and value respectively from the feature being labeled using the feature global variable. The code then initializes the color variable as undefined. It's going to then check the value of the value variable against a threshold of 100 using an if-else statement. And if the value is greater than 100, it's going to set the color variable to red. Otherwise, it's going to set it to black. Finally, the code returns an object with the custom label text and the color-coded symbol, which is constructed using the color variable. And the text property is set to the label variable, and the symbol property is set to an object with a color property set to the color variable. And this object can be used to customize the symbol of a labeled feature based on the value of its value field. We can also create custom expressions that calculate an area of a polygon. So this little snippet here of arcade code is going to calculate the area of a feature and return the value as the output. The feature.shape.area expression retrieves the area of the feature geometry, and it is assigned to the area variable. The return statement then returns the value of the area. We can also use Arcade to create custom symbols that change color based on an attribute value. So this Arcade code is going to be used to symbolize features in a map based off of a specific value called value. The code begins by creating a variable called value and assigning it the value of the value attribute of the feature being evaluated against the feature global variable. Then a variable called color is created without an initial value. Next, an if-else statement is used to evaluate the value attribute value and set the color variable accordingly. If the value attribute equals low, the color variable is set to green. If it equals medium, the color variable is set to yellow. Otherwise, if it doesn't match any of those values, it's going to be set to red. Finally, the code returns an object with the type simple fill and color value set to the color of color variable that was set in the previous step. This object can be used to define the symbol for the feature being evaluated, which in this case, the symbol is a simple fill with a color that depends on the value of the value attribute. So some of the benefits of using ArcGIS Arcade, custom expressions and calculations can be used across multiple ArcGIS products and platforms. So that means a custom expression that calculates the distance between, say, 2 points can be used in both ArcGIS Pro and ArcGIS Online Web Maps. And a custom expression that generates something like a unique ID for each feature can be used in both ArcGIS Pro and online feature layers. Custom expressions can be saved and shared with others. So a custom expression that formats phone numbers, for example, can be saved and shared with other members of a team, ensuring consistency and labeling across multiple projects. And a custom expression that calculates something like the percentage change in population over time can be shared with other organizations working on demographic analysis. Arcade can improve data visualizations and analysis. So using Arcade to create a custom symbology that changes based on the age of a building can help reveal patterns of urban development over time. Or using Arcade to create a custom calculation that identifies areas with the highest concentration of different land use types can help inform decisions about urban planning and zoning. All right, so we'll go ahead and jump into basic syntax. As mentioned earlier, Arcade expressions are enclosed in curly braces and can contain one or more statements separated by a semicolon. Variables can be defined using the var keyword, and values can be assigned using the equals operator. Functions can be used in arcade expressions to perform complex calculations or operations. And conditional statements can be used in arcade expressions to evaluate a condition and return a value based on the results. So, a quick recap, arcade expressions are enclosed in curly braces. Expressions can contain one or more statements separated by a semicolon, and statements can be commented out in both single line or multi-line comments. Let's jump into variables. Variables can be used to store and manipulate values. Variables are defined using the var keyword and assigned using the equals operator. And variables can be of various types, including string, number, and Boolean. So we have some examples of variables in Arcade. In this first example, this code is an arcade expression that calculates the population density of a feature by dividing the value of a field called population by the value of a field called area. And for this example, if the population attribute of a feature being measured is 5,000 and area attribute is 100 square kilometers, and the expression would return a value of 50, indicating that there's a population density of the feature 50 people per square kilometer. We can also store the results of a function to be used later in the expression. So this next code is an arcade expression that calculates the distance between a feature and the nearest city in a data set, and then creates a label with this information. For example, if the nearest city to the feature being measured is 50 kilometers away, the expression would return a label that says distance to nearest city 50 kilometers. And then storing the results of a calculation to be used for a label or tooltip. This next bit of code is an arcade expression that creates a label for a feature based off of its population. The label includes the name of the feature and a status indicating whether the feature is a large city or a small city. And for example, if the feature being measured is a city called Springfield with a population of 500,000, the expression would return a label that says Springfield, small city. So we'll talk about functions next. Functions are pre-written blocks of code that perform specific operations. Functions can be used to simplify expressions and reduce repetition, and functions can be nested within other functions and can accept arguments. We can see some functions such as the round function, which can be used to round a number to a specified number of decimal places. This example will round the population of a feature to 2 decimal places and divide it by 1,000,000. We have a count function that can be used to count the number of features that meet a certain condition. And this next example will count the number of cities in a data store with a population greater than 1,000,000. We have a date function that can be used to create a new date from an object string. And for example, this code will create a date object for February 23rd, 2023. We have an upper function that can be used to convert string to all uppercase. This example will convert a city name of a feature to all uppercase letters. And the last of these examples, which there are many functions available, is the concat function, which can be used to concatenate strings. And this example will concatenate the first and last name of a feature with a space in between. We have some text functions that we can take a look at. Once again, this is just a few. We have a left, which returns a specified number of characters in the beginning of a string. We can see from the comment that this is going to return hello. We have right, which is going to return a specified number of characters from the end of a string. And we can see from the comment here, this is going to return world with that exclamation point. And we have mid, which returns a specified number of characters from a string starting at a specified position. And we can see that this is going to return world. We have math functions. We can see the absolute value of a number. From the comments, we can see this first one is going to return 5. We have round, which is going to round a number to a specified number of decimal places. So this is going to return that simple pi of 3.14. And we have a floor, which is going to round a number down to the nearest integer. And we can see this is going to return 3, even though it's a .9. And then we have a couple of geometry functions we can look at now. We have length, which is going to return the length of a line or polyline geometry. We can see that this is going to return the length of the line. Area can return the area of a polygon geometry. And then we have the centroid, which is going to return the centroid point of a polygon geometry. So we can combine syntax elements in ArcGIS Arcade. So in this first example, we see that we have variables and functions that can be combined to create a more complex expression. First, the script is going to calculate the area of the feature using the area. Area is a special variable in Arcade that returns the area of the current feature in square meters. The script then divides the area by 1,000,000 to convert the area from square meters to square kilometers. And this is done by dividing the area by 1,000,000 area divided by 1,000,000, then resulting value is assigned to the variable area. And next, the script is going to calculate the population density by dividing the population of the feature by the area. The population density is assigned to the variable pop density. And this is done by dividing the feature.population, which is the population of the current feature, by area. Finally, the script is going to round the value of pop density down 2 places using the round function, which is built into Arcade. So that's going to round the number to the specified number of decimal places that you decide. And the resulting value is going to be returned by the script. So the entire script calculates the population density of a feature in square kilometers by dividing the population of its feature by its area in square kilometers, then rounding the resulting value down to 2 decimal places. And then we can see in our second one, we can use a variable to store the results of a function and then use that variable in subsequent calculations. So in this example, the length function is used to calculate the length of a line feature, and the result is stored in the line length variable. The variable is then used to convert the length to meters and round the result to 2 decimal places using the round function. And finally, the result is going to be used in a label expression to display the length in meters. Assuming the feature.shape represents the length of a line feature, the value returned would be a string that displays the length for the line in meters, rounding 2 decimal places. For example, if the length of a line is 50 feet, the code would convert it to 15.24 and then return the string length 15.24 meters. All right, in this section, we're going to talk about data manipulation. So we're going to explore how Arcade can be used to perform calculations and manipulate data on the fly without the need to create new fields or tables. As we've said before, Arcade's a powerful scripting language that can be used to create custom expressions and calculations for use in maps and data analysis. And with Arcade, you can filter, classify, and label your data in new dynamic ways. So Arcade can be used to calculate fields in ArcGIS. You can use an Arcade expression in the field calculator to calculate new values based on existing fields. Arcade can be used in labeling expressions to display calculated values on a map or in pop-up expressions to display the calculated values for individual features. We can see some example of this. We can see calculating a percentage based on 2 fields. This Arcade expression calculates the percentage that one field value represents of another field value in the same record. We can concatenate values from multiple fields. So this Arcade expression concatenates the values of 2 fields in the same record into a single line. And we can convert units of measurement. So this is an example of converting meters to feet. Arcade can be used to filter data in ArcGIS. You can also use Arcade expressions and definition queries to filter features based off of specific criteria. And Arcade can also be used in pop-up expressions to display only certain attributes for individual features, or in a labeling expression to display only certain labels on a map. I'm going to try to go a little bit quicker to kind of look at the time. I want to make sure Gustavo has enough time for his presentation. But we can take a quick look at some examples of Arcade expressions that can be used to filter data in ArcGIS. We can look at this top bit of code here that's going to be an example of Arcade expressions that uses Euclidean distance to filter features based off their proximity to a point layer. We can display only features with values above or below a certain threshold. And this is going to be an example of a Boolean expression that uses logical operators to evaluate 2 conditions and return a Boolean value, which would be either true or false. And we can also display, only features that meet multiple criteria. So this is an example of a multi-criteria filter using 3 fields. We have field A, field B, and field C. And the code will return true only if all 3 conditions are met. We can also classify data using ArcGIS Arcade. We can use arcade expressions in the classified dialog group to value into classes based off of specific criteria. And arcade can also be used in labeling expressions to display values as classes on a map, or in a pop-up expression to display values as classes for individual features. So this is an example of value classification based on a single field called value field. And this code is going to use if-else statements to check if the value in the field, and then it's going to return the appropriate category based off of the value. We can also classify data based off of geographic location. So this code calculates the distance between the current feature and the city of Seattle and classifies the feature as urban, suburban, or rural based on the distance. And the actual distance classification thresholds and labels can be modified as needed. So you can combine multiple data manipulation techniques in Arcade to create more complex expressions. For example, you can use a combination of field calculations and data filtering to display only certain values based on calculated criteria. And you can also use a combination of data filtering and classification to display only certain features within specific value ranges, or a combination of classification and field calculations to group data categories based off of their calculated values. And then we're going to jump into labeling with Arcade. So labeling with Arcade is going to allow you to create dynamic labels that respond to changes in your data or map settings. Arcade expressions can be used to customize label placement and formatting, giving you greater control over the appearance of your labels. And overall, Arcade provides a powerful set of tools for customizing labels, allowing you to create clear, dynamic, and informative maps. So some of the basics: labeling with Arcade is going to allow you to create dynamic and customized labels for your maps in ArcGIS, and Arcade expressions can be used to format and style label text based off of specific criteria. Arcade is going to allow you to concatenate values from multiple fields or add text to labels, and it's also going to allow you to create custom labels based off of specific criteria. So a couple of examples: we can use expressions to format labels based off of specific criteria. In this expression, the variable declares a variable, text formats the number with commas, round rounds to the nearest 1,000, and the K concatenates the K at the end of the label. We can concatenate values from multiple fields or add text to labels. In this expression, the plus operator concatenates the values from the two fields. And this is going to allow you to add text before and after the concatenated values respectively. And you can create custom labels based off of specific criteria. So in this expression, the if statement is going to check if the population is greater than 10,000. And if it is, it's going to return the value from the name field. And if the population is less than or equal to 10,000, it's going to return an empty string, effectively hiding the label for those features. We can use Arcade expressions to format labels based off specific criteria, concatenate values from multiple fields. We're adding text to label and create custom labels based off of specific criteria. So we just kind of went over. So you can also do some advanced labeling techniques, which is going to allow you to add labels with complex expressions that combine multiple data manipulation techniques, such as conditional formatting and string concatenation. Apply visual effects, such as drop shadows, outlines, and halos to improve legibility and enhance your appearance of your labels. Dynamically adjust label formatting based on real-time data feeds, such as weather or traffic conditions, to provide more timely and relevant information to the user. It's going to allow you to use Arcade expressions to create stacked labels, which can be useful when displaying multi-part information, such as street names and house numbers. This next bit of code is going to show how you can use Arcade to determine the current map scale and then set a text format based off of that scale. And in the second example, we can see that the type attribute of the current feature is checked, and then resulting that the text format is set accordingly. So some of the best practices for labeling with ArcGIS Arcade, make sure that your Arcade expressions are being used to create dynamic labels that change based on data and map scales to keep those visible. Keep label expressions simple and efficient to avoid slow map performance, and keep variables and functions organized so you can be able to reuse and label your code, and make sure to make use of your comments to make them more readable and understandable. Keep your labels simple and easy to read with appropriate font sizes and styles. Keep label styles consistent and formats similar throughout the map. And test labels at different scales and on different devices to ensure that they are legible and well placed. So formatting labels based off of specific criteria, we can use arcade expressions to create custom labels based on data values, such as combining fields or formatting numbers and dates. In this next example, we can see that we can display different labels based off of a field value using the immediate if function. And in our last example, we can see how we can capitalize the first letter of each word in the label using the proper function. You can concatenate values from multiple fields to add text to labels. And so we can see this example of creating a full name from separate first and last name fields, and using that expression with the traditional concatenation, or we can use the concatenated function to achieve the same result, as you can see in the second version of the script here. We can use custom labels based off of specific criteria. So we can use if-else statements to create conditional labels based off of data values, such as displaying yes if a value is true and no if it's false. We can use statements to create labels with multiple possible values, such as displaying high, medium, or low based off of a data range. For example, in this second code here, we can see how we display different labels based off the range of values in a pop density field. And in this last example, we're going to take a look at using labels to create a label for distance field that combines value in kilometers and a value in miles. So we can see both of those here used with this arcade expression. Last, I'm going to try to breeze through this here. We got visualizations. Dynamic visualizations in arcade involve using arcade expressions to create custom styles and symbols that change dynamically based off of the data values in a layer. And this is going to result in more impactful and informative map visualizations. And we go ahead and quickly take a few, look at a few examples of this. So using arcade expressions, we can create conditional symbology based off of data values. We can use arcade expressions to create dynamic charts or graphs, and we can use arcade expressions to display data in a creative way. So this example here is going to calculate the population density per square mile for a feature, and then it's going to define a gradient color ramp to symbolize different levels of the population density. And the result is a conditional symbology that colors the feature according to their population density, with lower density features having lighter colors and higher density features having darker colors. This next expression is going to define a dictionary object, land use symbols, which associates different types of land use with specific symbols. For example, if the land use type attribute of this feature is residential, the expression will return house. We can create custom symbols or patterns to display data in a more visually appealing way. And this ArcGIS arcade code is going to define a custom symbol for water bodies and return the custom symbol for the water features while using the default symbol for other features. And then there's some advanced visualization techniques that we can do. There's the ability to create some, transitions or animations, create interactive visualizations, and you can combine multiple visualization techniques to make your expressions more advanced. So looking at some of the best practices, make sure you're choosing a clear and appropriate color scheme that's easily read and understood. Use consistent symbology and visualization techniques throughout your maps, and make sure to test your visualizations based on different devices and screen sizes to make sure that they're legible and impactful. And with that, I'm going to go ahead and hand over to Gustavo, and we will go ahead and take a look at some of this in action.
In the last 20 minutes or so, we're just going to take a look at some of the things that Phillip mentioned in practice here. And this is not really intent to make you an expert in all the functions available or the variables or anything like that. It's more, where is Arcade available and how can I start writing some code in those profiles? And I want to start with documentation here just to make sure that after the session here, if anyone has to leave early, you are aware there is a really good documentation, all the topics that we're going through. I also want to talk a little bit about this idea of a profile within Arcade, because depending on what you are trying to change, if it's the label or the visualization or the pop-up, those are different profiles that you're going to be working with. And you can see here a list of those profiles and where they are available. So for example, if you're doing something in ArcGIS dashboard, maybe you're not going to see any options to do attribute rules there. It's just going to be something more on the visualization side of things, just a hypothetical example. And same thing with some of these other ones, right? If you're working with maybe GeoTrigger, you're not going to see anything related to pop-up here. So it kind of, what you're going to see on the editor, it's going to be a little different. And I can show that in ArcGIS Online in a second, but I just want to make sure that we talked a little bit about that. And then, like I mentioned at the beginning, I'm not going to go through any specific functions here today, but if you have done any JavaScript or Python before, you're very familiar with a lot of these functions. If not, if you're kind of brand new to writing any type of code, you can come here and you can find specific functions that will help you accomplish something specific that you're trying to do. And then again, if you don't want create a whole project, and if it's the first time that you're just getting started with this, there's a playground here where you can explore some of the variables, the functions, and type some code and see the results. So with that said, I'm gonna start the demo. I also wanna mention something. If you go to the ArcGIS blog, you're gonna see there's a lot of what's new here, because in the last couple of days, they released a new release of ArcGIS Online. And I'm gonna use a little bit of field maps today. And if you come here, you're gonna see that one of the things that changed is Arcade, where you access things. So if I'm having a hard time finding a button, it's because it just changed the interface, but I think I'm good because I test things this morning. But and this is a good reminder too, that Arcade is always evolving, right? It started more as a visualization, so kind of last section that Phillip went through there. But then over time, they added support for label and pop-ups, and now even as a developer, you can kind of have full control of the whole Arcade experience and include that in your apps too. Okay, with all that said, for the demo today here, I'm going to use one of the ArcGIS solutions, and I just use the damage assessment solution. So if you're not familiar with ArcGIS solution, that's kind of another topic, but it's basically pre-configuration of different applications that Azure provides. So I'm using this just so that ArcGIS Online creates some layers and maps and applications for me, and I don't have to create those from scratch. And if I go to my content, I can see a lot of those items that were created. And this is kind of the map that I started with, and I just made some simple improvements here using Arcade, and that's where I'm going to spend the next 10 minutes or so going through. So you can see, if I look at the label here, it's not the best format to show the label, right? It's not easy to understand. So I think we can make that look a little better using Arcade without, I think before maybe you would have to go to the schema, create a new field and have to change the type and find a way to make this a little bit more easier to read. But with Arcade now, we can kind of do that without having to go to the schema and add additional fields to the data. Another thing, if I click on one of these features, the pop-up is very simple right now, and it's going to remain basically the same. I didn't really customize the entire pop-up experience, but I'm going to add maybe a title and a description here so that it's a little bit easier again to understand, or I can use those sections to provide some additional information, even if I don't want to mess with the pop-up. But If you want to take a step further, you could really customize this, have links and images and things that I'm not going to go here today, but just want to mention that's possible. And then also when I'm editing things, let's say I'm going to add a new affected area here. I'm going to show how you can customize the form in field maps and how Arcade can be helpful there too. So this form is very long right now, and I don't know if there's any automation here in terms of capturing date and the user that's doing the editing. So those are some of the things that we can do using Arcade too. I think that's what I want to mention on this map. Going to the second one, the one that I made the changes, you can see that the date now, it's a little bit easier to read. Maybe you want something different, but I think that's kind of the standard that most people are used to. If I click on the icon here, you can see now I have a title, and the index is just a string that I type the word index. But then the number here is being calculated with Arcade, and this is just a hypothetical number too. It's nothing meaningful here, but for the purpose of the demo, I'll show you how you can do some of those calculations using Arcade. And then the description is the same. It's just a string that I typed this whole kind of first section here. And then this value here is dynamically based on the features. So if I click on this one, you can see now it's saying this one is affected, but everything else the same. The index changed because there's some numbers that I entered here are different. So if I go to field maps now, and I click on this one is actually the original one. You can see I don't have any form created here. I could convert my entire set of attributes to the form. I can add additional things, but I'm going to actually do a different one here that I configured for this demo. So when I open this map, I have the form that I configured with just a couple of fields. And you can see that some of these are using calculations, and some of these are also going to use functions that will capture values without the user having to enter that information. So another thing that you can do too is conditional visibility. So this one here, you can see there is a tag visible here because I have some logic here that is basically saying when this is going to be visible and when it's not going to be visible. So here's the kind of first Arcade example. It's just grabbing a domain name, and then if it equals major, then that additional question will be shown on the form. If not, then that question won't appear. And you can type the code yourself if you launch the editor, but in this case here, there is also a nice user interface that you can just select the options, and then it will kind of change that to you. So if I change this to minor, you would change that. I'm not going to change this to make sure that the demo works here, but you could change over here too. So that's conditional visibility. And that's one of the things that changed with this last release of ArcGIS Online. This was a little different before if you have been here, but now you have this kind of settings icon, and that's how you access things, and it just looks a little different. So that's conditional visibility. You can also do calculations. So if you look at the calculated value here, and if I go again here, and it's using this index. If I go edit Arcade, it's just a very simple expression that's grabbing the value and then multiplying by another, right? So it's grabbing the attribute impacted units for that specific feature and then multiplying by the areas of damage. So that's another very simple, but you can see if I expand this here now, that's the notion of working with a profile. I see feature and layer and data store because those are things that are available in this profile here. When I go to the map viewer, I'll open something, for example, working with labels, and you're going to see that you're not going to see the same options. The functions, they might look very similar. It's just kind of a comprehensive list of common functions that you might be using, but the profile here are going to be specific for that the application that you're using, for example. And then this one, it's another example of how to calculate something. But in this case, actually, it's here. No, it's down here. In this case, it's just using a function to grab the user's name. So it's looking at the layer and then just grabbing the user that edited this layer. And then same thing for the date here. There is another arcade expression called date that I created. You can see that it's using that because I can select and unselect things here, but I want to keep that date one. And if I open, it's a very simple function called now that's just going to automatically enter the date at the time that the feature is being collected or edited or whatever the attribute is representing. So that's kind of what I want to show here. If I go back to my map, I want to show a couple additional things. If I go to the labels, and I think a challenge in the beginning when you're starting work with Arcade is just knowing where the buttons are. And it's usually something that looks like this, or it's something that you're going to see the word expression. So let's say I go to the pop-up and I'm editing my title. You can see this one looks a little different, but there's an icon here. And in some cases, there will be something that says create an expression. So let's go to the symbology. You can see this one says expression. So it's just getting familiar with those icons and where they are. But again, if I go to the labels and I click here, and it's going to launch this, and that's how I change the label. It's just a month function and then captures the month from this date field, then plus a string just with a slash here and the day, the same idea, slash, and then the same idea. But if I expand this here now, you can see there's only one global variable available for this, right? I can't really do things with the whole map or the whole layer. It's just the label for the feature. If I go to the pop-up, let's take a look here quickly. If I click here, and let's pretend we're adding a new expression, and I click on this. Now you can see I can add things related to the future, related to the layer that can have multiple features, the whole map, or the data store. And I can expand this to look at the attributes, right? In this case, because the damage assessment features and layers here, they come with a lot of attributes. That's why there's a very long list. But it could be that your layer will be just a few attributes here. Same idea for the functions. You can access the functions here too. And we're kind of almost running out of time here. So I want to show something a little bit more complex. And this might be a good way for you to get some ideas of what can be done too. If I go to the Living Atlas and I type, for example, air quality, I'm going to find some layers from Esri here. This one, you can see there's some more interesting symbology here. I didn't want to mess up with the symbology for the damage assessment because it's very specific icons and colors based on status. But if we go to the Living Atlas, grab a layer and you like the symbology that it's being used, then you can click on that layer. Let's look at this one here. Let's go to the symbology. And then there is an arcade expression that sets the symbol size based on the map scale. So if I click there, you can see now, instead of my simple examples with just one line of code, it's something more like what Phillip showed on the slides here, right? So there is variables being declared, some function and when being used here for different things that I want to do with the symbology, and then return something in the end. I think that's all that I'm going to show here. The last thing that I want to show quickly is that Phillip mentioned during the presentation that one of the major benefits of Arcade is that I can write something like you saw before. I wrote something in field maps but it's also available in the map viewer and in any other applications that I embed this map or that I create using this map. And that applies to desktop environments too. So if I look at my map here now, and I just went to my portal, I'm using ArcGIS Pro, so I can quickly open everything that I have in ArcGIS Online or ArcGIS Enterprise. So portal here, it's not the portal that comes with Enterprise, it's just a WebGIS portal. Then I found that web map that I showed before in the map viewer, and then I just add to my project. And now you can see that the symbology or the label is the same. And if I click on the future, the title here will be the index to just like before, right? And if I want to make changes to things using ArcMap, I can do that too. So for example, I would select one of this, one of the layers that I have, and then I click on the labeling, for example, and then the same idea here will be expression or an icon. And then when I launch that, you can see that same function that I showed to you before. And if I want to make any changes, maybe I want to delete some section of this, you will change here. And if I save and I open ArcGIS Online, the same experience, that everything that I see here is what I'm going to see there too.
Oh, thanks, Gustavo. So a couple of things that were just mentioned. Follow the blogs for good information. We did just have a update to ArcGIS Online. This post came out yesterday, but we had our February update. You can read all about all of the new functionality. A big update that came with the November release was that ArcGIS Arcade editor that Gustavo demonstrated, which makes it much easier and that kind of rich coding experience to be able to build your expressions, test them really easily. So it should really take away, if you have any anxiety about writing codes, like I mentioned, I'm not a coder. This makes it much easier to be able to build those expressions and kind of give that predictive kind of format as far as trying to figure out what it is you're trying to accomplish. And then, there's plenty of resources that we have available. There's the documentation, there's the playground, there's tutorials. We have, robust community with the forums for Arcade. There's, webinars. So there's, any kind of entry point to kind of get started. I know I like, watching these demos and videos, going back to the documentation and trying stuff out to see if I can, kind of accomplish the same thing that some of these other folks are doing. And then always, you can feel free to reach out to either Gustavo or myself. If we have questions that we can answer, we can certainly do that. And if not, we can always pass that along back to the sort of subject matter experts and make sure that those questions get addressed by the right people. And I think that we are right at time. So I want to thank everybody once again. I know Gustavo and I are really, sorry we couldn't be there in person, but hopefully this was informative and will encourage you to use Arcade more, across the platform in your mapping endeavors. So once again, just want to thank everybody and hope that everybody has